Okay, so what we really want to do is break this down. We're going to simplify each expression. We want to break this down into what it really says is 4 times a times b to the 0. And which part of this do we know? Well, we know that b to the 0 equals 1, so that's like, we can say that's the same as saying 4 times a times 1. Well, the times 1 isn't really going to change anything. Anytime you multiply it by 1, you don't really change anything. And what do you get there as a result? Then you get 4a. That is the answer. Okay, let's keep going with this. 5x to the negative 4, that's really like saying 5 times x to the negative 4, which is equal to 5 times 1 over x to the 4th. Okay? And actually, let me write that down below, just to give us more space. So 5 times 1 over x to the 4th. And you should know that anytime you multiply a whole number by a fraction, the whole number multiplies the numerator. So we can write 5 times 1 over x to the 4th. And that equals 5. Again, you're multiplying that whole number by the numerator over x to the 4th. Okay, let's keep going. So a fun thing to know is that the negative of an exponent takes whatever the base is and it jumps it to the other side of the fraction bar. So if we were looking at number 25 here below, we would say this 3 to the negative 2 power, that's actually going to jump to the bottom as 3 to the positive 2 power. Okay? The negative of an exponent tells you to jump the fraction bar and use up the negative in the process of that. Okay? So another way of doing that is saying you can move something from one side of the fraction bar to the other side by changing its sign. That's really the rule. If you write it, the exponent with its opposite sign, then you then have it on the other side of the fraction bar. Okay, so let me show you what that means here. Well, now we've still got n on the bottom. Okay, but now we've got that 3 to the second power, this right here. We've got that jumping the fraction bar to be down here as 3 to the positive second power. And what happened, what's on top now? It doesn't look like there's anything left on top. Well, if there's nothing left on top, we got to call it a 1. Okay? Now we can resolve 3 to the second power. 3 to the second power is 9. So we end up with 1 over 9 times n. And that equals 1 over 9n. Sorry, I had a little technical difficulty there. All right, let's keep going with this. Number 27. What's going to jump the fraction bar? What has the negative exponent on it? Well, there is not parentheses around this 3x. So that negative 2 exponent is not working on the entire 3x. It's actually only working on the x. It's only attached to the closest thing it's attached to. Unless we attach more than one thing together, the 3 and the x, together with parentheses, then it's only working on the x. And what does that mean for us? That means that you have the 3 remaining on top, but the x to the negative 2 now is down here as x to the positive 2 times y. Yeah? Okay. Then what we do is we say, okay, we're going to simplify this into 3 over x squared times y is just x squared y. And actually, there's nothing else that we need to do for that. We just box it, and that's our answer. Okay. Typically, what you do is you write these in alphabetical order. So you'll put the x's first, then you'll put the y's. The reason for that is then we have consistency. Everybody's writing them in the same order because we know what order to write them in. Okay. Excuse me. Actually, what I should write there, no, that's fine. Okay, I'll just keep going. So number 27, or 29 rather. What we've got here is we've got really c to the negative 5 times d to the negative 7. You can see that they're separately, they have the separate exponents and all that. Okay, and really you could imagine that as over 1, like that. Because now the c to the negative 5 jumps the fraction bar. Fraction bar is here. The c to the negative 5 jumps the fraction bar. And in the process of doing it, it uses up that negative on the exponent. So it becomes a positive 5. And the d to the negative 7, that also jumps the fraction bar to the bottom to become a positive exponent of 7. Now what's left on top? I don't see anything on top, so I put it as a 1. And what does it mean to be 1 over c to the 5th times c to the 7th? Well, all you do is you call it 1 over c to the 5th, d to the 7th, pushed all together and multiplied together. Sorry about that crummy little boxing there. Now, let's keep going. This is really 8 over 2 times s to the negative 3. And what's got that negative 3 on it? Just the s, because this doesn't have parentheses around it, so it doesn't move the whole thing to the top when it finally moves. It's only simply going to move the s. So let's do it. We get 8 over, 8, and then that s to the negative 3 jumps up to s cubed, s to the 3rd on top. What's left on the bottom? The 2. But notice something else, actually. That 8 from up here and this 2, that 8 can be divided by that 2 to make them go away. So what you get then is 8 divided by 2 is 4, 4s to the 3rd. And there's nothing left on the bottom but a 1, but you don't really need to write over 1. You need to write under 1. If there was 1 on top, like there was in 29, it's got to be there, otherwise you don't know that this is in the denominator. Okay, but for this, you can just write it as like the whole number. Yep. 4s cubed. Okay. Let's do these last ones. Let's see. We've got, I'm going to rewrite this out, breaking everything up. We've got c times a to the negative 1 times c to the negative 3 all over d to the 0. Okay, so what? Well, let me box that last answer. Okay, so what? So what you've got now is you've got a 6 on top. This d to the 0 on the bottom, that becomes a 1. So we don't need to show it anymore because it's just a 1. And there's going to be other stuff on the bottom anyway. That a to the negative 1, that negative jumps that a to the first to the bottom to just be a to the first. And a to the first is just written as a. Okay? We also see what's jumping the fraction bar, that c to the negative 3. That's got a negative on it, so we'll jump that fraction bar to the bottom, and we'll call it c to the positive 3. Yeah? And of course, those are being multiplied together, which means that ultimately all we're writing is 6 over ac cubed. And again, you can see that this cubed is not acting on the a. It doesn't have parentheses around it there. So that's not making, it's not cubing a and c together. It's simply just cubing the c. And you can see that they're separate here. Even though they're sitting together here, it's actually first doing this power, then multiplying with the results. Okay, box that. And one last problem to do on this, which is we're going to write this out what we know. We've got 12 to the 0 times t to the 7 times u to the negative 11. And what is that doing for us? What do we have to do to it? Well, 12 to the 0 is just 1. So that just becomes a 1. And t to the 7 remains, because it doesn't have a negative, so we don't jump it over. But u to the negative 11 does. So now we've got to write a fraction bar. Here we've got our t to the 7 on top. And then that u to the negative 11 is going to jump to the bottom as a u to the positive 11. It uses up the exponent in order to make that jump across the fraction bar. Okay? And that's it. There's no other way to simplify that. You can always divide coefficients. If there was a number in front of each one, we could divide them if it was possible. But in this case, there's not. And that's all we got. We are done.